In this lecture, we'll talk about OTD or Mana Alutam or Zora, Tanav, Dabav, Khichav or stress. So how to define this stress actually? So let's pick up three important personalities of this universe, which is Tom, Dick and Harry. And let's consider we have a body. And in this body, there are three different molecules. Okay, Tom, Dick and Harry. I have shown this in a 3D diagram in order to make you visualize things, how the things are changing out here and how this concept actually works. So here we'll talk simply about the concept of stress. The types of stress will be dealt in the next lecture. So for your analysis, what I have done is I have taken only a single type of force, which is a tensile force, right? So other types of forces may be compressive, bending, shear, all those things will be dealt in the next lecture. But for the time being, just focus out here. So let us consider we have a body whose cross-sectional area is A, and I have taken a uniform body in order to simplify our analysis. So two forces are there which are acting on opposite directions, and these forces are tensile in nature. You know this. What is the nature of the force? Here the nature of the force is tensile. Okay, now three different molecules, we will see the effect of these forces on these three different molecules out here. So here what is going to happen, say if I am applying a force in this direction towards left, what Tom will try to do, Tom will try to oppose it, and Tom will try to apply a force just opposite of this F. Understand once again, I am applying a force externally towards left. Due to this externally applied force, Tom will oppose this motion or force and will try to resist, and that type of a force I am naming it as P1. Okay, so this P1, which is, as you can see, it is going towards right. This is the reaction of this action. Which is action? This is my action. What is my action? Externally applied force towards the left hand side. Clear? Now externally applied force towards the right hand side, which is this F. Due to this, Tom will also apply an opposite force. I am naming this as P2. Clear? Due to this left hand side force F, there is a reaction P1 which is towards right. Due to this right force F, there is an opposing force P2 which is acting towards left. Okay, so this is an action and P1 is the reaction of this. F is an action which is going towards right, and due to this F, P2 is the reaction of this. Similarly, another molecule, just the neighbor of Tom, which is Dick, this will also apply a force, let's say P3 and P4. P3 is due to the opposite resistance due to this F. P4 is the opposite resistance due to this F. Okay. Similarly, another neighbor, which is Harry, this will also apply a force, let's say P5 and P6. P5 is the force which is being applied opposite to this left hand side F, and P6 is the opposite force which is being applied due to this right hand side force F. I hope you got this. Once again, you understand, I am applying an external force, due to which there is some reaction which is happening inside the particles or the molecules. So we are seeing things in the molecular level, which is, I have, for your simplicity, I have named this. These I have taken three different molecules and I have named it as Tom, Dick and Harry. So for Tom, what is happening? Due to this F force, P1 is the opposing force. Due to this right hand side force F, P2 is the opposing force. Same goes with Dick, same goes with Harry. Clear? Now you see once again, what is this F? I will call this as to be my external force. Clear? What is P1 and P2? P1 and P2 are nothing but internal force. Who is applying this external force? I am applying. Who is applying this P1 and P2? Dear, P1 and P2 are not being applied. They are generated. They are generated or developed. So internal forces cannot be applied. If anyone says apply an internal force, he's a fool. How can you apply an internal force, man? Can you get inside this body and apply? You cannot go inside this body, right? So that internal force will be generated or developed. You can only apply external force. Okay, so this is the internal force concept. This is your external force concept. Moreover, if I say capital F, if I divide this capital F to that of area, what does it mean? It doesn't mean anything actually. I can simply say this is external force which is tensile in nature divided by area, and it doesn't have any sense. Okay, sense, obviously it has a sense, but it's not having any particular term. You cannot confuse this with pressure. Many people will say this is pressure. No, this is not a pressure. I won't call this as to be pressure. What is pressure? We will learn now. Here you see, I have taken an external force which is F. I have divided with the cross-sectional area A, and I am naming this as tensile external force per unit area. Okay. Now, if I divide this internal force, let's say if I am dividing this internal force, let's say I am taking this internal force P1 and I am dividing with area, I will call this as to be my internal force per unit area. And this internal force is which nature? It is of resisting nature. Resisting nature, which is tensile. If I am applying an external tensile force, then definitely there will be an internal tensile resisting force. If I am applying an external compressive force, there will be always an internal compressive resisting force. Is that clear to you? Now here P1 will be equal to P2. Why? Because the same amount of force is being applied on the left hand side, same amount of force has to be applied on the right hand side. So this is the nature that you should remember. Okay, so that is why we call this as to be internal resisting force per unit area, and this term is called your stress. And hence we have concluded the definition for the stress is, we can say that what is stress? Stress is the internal resisting force per unit area of the material from which the component is made. Clear? Now see one more thing interesting. Here we are talking about Tom. So this Tom is applying some internal force, let's say P1, and on this side let's say P2. Now Dick is also applying on this side, let's say P4, and on this side let's say P3, and Harry is also applying on this side, let's say P6, and on this side let's say P5. Now can it happen that whatever the force which is being generated due to this Tom gets shifted towards its neighbor? Yes or no? Yes, of course, since they are very near, so this will get shifted, so which we call about the line of action of the force. Yes, similarly you can say whatever the internal force which is being generated at this point can be shifted like this, so we can call this thing as your stress transfer. What we call this? We call this as stress transfer. So we won't be talking much about this stress transfer and stress transfer function because that will be beyond the course. I just gave you a hint. Yes, that's also possible because we know that the line of action of force. Okay, that is the complete story of your Tom, Dick and Harry, which is your stress. So the purpose of telling this was, you cannot say this external force which is tensile in nature divided by area as a pressure. What will be the pressure? Now see here. If I take the same body, okay, same molecules are there, but the nature of the forces I have just changed. The nature of the external force, I told you, what is this? This is my external force. What is this? This is my external force. This is also external force. Okay, so if I am applying an external force out here, now what is going to happen? Since I am applying an external force which is compressing this body, so Tom will say, please don't compress me. Okay, so it will resist it. It will resist it. So here the nature of the forces which are being applied externally is compressive. So here the nature of the stress which is being generated will also be compressive. Please make sure of this. If you are applying an external tensile force, there will be generation of internal tensile stress. If you are applying an external compressive force, there will be generation of internal compressive stress. The nature of the force becomes equal. Okay, so here if you are applying tensile, internal also it will be tensile. If you are applying shear, internal also it will be shear. That was the purpose of telling you. Okay, so this was basically the concept of stress. Now here let us consider, this is my cross-sectional area, and let's say this, I am naming this as P and P. I have taken only this particular thing, and we know that this will be equal. Now if I write P divided by A, I will call this as to be my stress. Now if I write capital F by A, then I will call this as to be pressure. Now you will be asking, sir, here you are writing Pf by A not equal to pressure, and here you are writing F by A equal to pressure. Why, sir? Dear, here F is your external force. Yes, of course, but it is of tensile in nature. Here F is an external force, but it is compressive in nature. So you should always remember that your pressure is always compressive in nature. Pressure is always compressive in nature. And second point, it always acts perpendicular to the surface. It always acts perpendicular to the surface. Clear? Now let's play. I am applying some inclined force out here. Let's say F. Let me name it. Let's say this is G. Okay. Now if I ask you, tell me what is G by A, you will say, sir, it is nothing. I cannot say this. But I will take the component. Let me take the component along this. This is my horizontal component, and this is my vertical component. Clear? This is my horizontal component, this is my vertical component. Let's say the angle made between this is theta. So this component will be what? G cos theta. What is this component? G sin theta. Clear? Now if I write G sin theta divided by this cross-sectional area, I will call this term as my pressure. Clear? I hope you got the point. Difference between what is stress, what is pressure, and what is all these stress transfer and all these things. Okay, so just we have introduced the concept of stress. In the next lecture we will just see the types and different forms of stress. See you in the next lecture. Till then, bye.